That was an unexpected break in the video. My computer lost power, went dead. I was not paying attention, and I need to put the power cord and connect it. So here we are back again. So here we are at 49. I was talking about symmetry and trying to figure out how do we know, don't know. This has to do with, is this an even function or an odd function? There's a quick little test to do that. Take a positive number and take the opposite of that and plug them in and see if the answer is the same or if the answers are opposite or neither. So if I plug in positive 1, I get the answer positive 1. If I plug in negative 1, I get the answer positive 1. Because I get the same answer, that means this function is even and it has symmetry with the y-axis. That's simple. If you plugged in positive 1 and got the answer 0, you'd have to plug in a different positive number and its negative partner and look at the answer. 50. Same kind of question, but for 50 it's g at x, and it's x cubed, subtract the cubed, minus x plus 3. So if I do a quick test here with positive 1 and negative 1 to see the symmetry here. So if I plug in positive 1, I get the answer 3. If I plug in negative 1, be careful, negative 1 cubed is negative 1. A negative and a negative is positive 1. So I got negative 1 plus 1, and it's 3. Did I do it right? How about try another one? Because I feel this just feels a little bit off right now. That's 8, take away 2 is 6, plus 3 is 9. Negative 2 would be negative 8 plus 2, which is negative 6, plus 3, which is negative 3. So when I plugged in 1 and negative 1, unfortunately, it gave me the same answer, but something felt off. This is what felt off. Think of this as x to the 0. I have an odd exponent, and 0 in this situation is considered even. 0 goes with 2, 4, and 6, and so on. So there is a mix of exponents. So I had a strong feeling that when I plug in a positive number and its opposite partner, that I was going to get two different answers. This just happened to be the setup and gave me the right answer, but this was a throw-off. This is what I was looking for. So this is neither. It has no symmetry with y, the x, or the origin. All right, 51. In question number 51, find the inverse. A little bit of pre-cal math 3 kind of stuff. The cube root of x minus 2. To find the inverse of a function, x and y are inversed, and then solve for y. So what's the inverse of cube root? It's cubing, so I cube both sides. And then to get y by itself, I add 2. Now the symbol for inverse is that little negative 1. And then it's x cubed plus 2. That is the inverse. There's no domain restriction for cube root. Positive, negative, 0 all work just like cubing, so we don't have to worry about restrictions here. It's all real numbers. 52. It says, use the graph. So I got to look at the graph. So use the graph shown to the following and see if you could graph. So if that's f at x, what would the absolute value of it look like? So looking at this graph, if I want to know what the absolute value of this graph looks like, that would mean all negative values would be positive. So I'm first going to take the points that I see. So I see negative 2, 1. It's already a positive answer. 0 stays. A positive answer, 0. The only part that would change is this down here. So that negative answer, instead of having the answer negative 1, that answer would go up to positive 1. So the absolute value would look like this. So to regraph it, negative 2 and positive 1, negative 2 and negative 1, 0 and 1, 1, 1. This last part, instead of going to 2 and negative 1, it goes to 2 and positive 1. In fact, whatever is below gets reflected up. So this is still going to look like a parabola. This is a line, this is a line. So these are line segments, so like a U and a V right beside each other. Cute, right? 53, what would it look like if it was now, oops, I should have said Y equals. If now you're graphing and it says f at x minus 2 plus 1. So what would that do to the graph? Well, what would happen is, what's happening inside would shift it 2 to the right, because it goes in the opposite of what you see. And this means 1 up. So can you go 2 to the right and 1 up, and then regraph it? So what would that mean if you went 2 to the right, sure I have enough room here, and then 1 up? So when I look at the first point, if it's 2 to the right, it's now here, and then 1 up. So 2 to the right and 1 up would mean it would be right here. So now the point is at 2, 2. The next one, if I went 2 to the right and 1 up, would be right here. The next one, if I went 2 to the right and 1 up, it'd be here, and this would connect like a U. The next point would be 2 to the right and 1 up. That's where it would end up. And the next one, 2 to the right and 1 up. And then that's what it would look like. So that's what it looks like when it's 2 to the right and 1 up. So take each key point, 2 to the right, 1 up, and then redraw the curves or lines. Last one like that, 54. If the function was negative 2 f at x, what would that do to the graph? So negative means a reflection, and 2 means it's been stretched. And this is all the y-coordinate. So take only the y-coordinate and multiply it by negative 2. So the first one went 2 to the left, that's the x-coordinate, and the y-coordinate was 1. So if I go 1 times negative 2, it's now here at negative 2, negative 2. So only the y-coordinate times negative 2. The good thing about 0 is it stays there. So negative 1, 0. When you take the y-coordinate, 0 times negative 2, the answer is still 0. The next one was at 0, 1. If I take 1 and multiply it by negative 2, it's now here, and this is going to be a curve, a parabola. See the reflection there when you multiply it by negative 2, and it's a little bit stretchier. It has a little vertical stretch to it. The next point, again, is at 0. So that 0 stays that when you multiply it times negative 2. And the last y-coordinate was positive, was negative 1. So negative times a negative, the last one would end up at positive 2, right here. And then draw a line. That's a transformation that you did, some Math 3 pre-calculus review. Could you transform a function like that? Done. 55. So in number 55, find the domain, vertical asymptotes, poles, intercepts, and end behavior, and so on for this function. So can you analyze and graph it? So let's do that together. Step 1 here is to factor. So I'm going to factor the denominator. X squared subtract 1 is a difference of squares. Then, what's the domain restriction? What can x not equal? Look at the denominator. It can't equal negative 1, and it can't equal positive 1. Then we're going to reduce it down. So divide it out, and you're left with x over x plus 1. What just got removed? That means positive 1 is a hole, because positive 1, that restriction was removed. It creates a hole. Negative 1 remains. So you can see that's a vertical asymptote. So we have a hole at positive 1. And when I plug positive 1 in, I get 1/2. And we have a vertical asymptote of what's left over, which is at x equals negative 1. The end behavior here for the horizontal asymptote, notice the top and bottom are equally powerful. So when I divide it, I get the answer 1. So x divided by x gives me that. That's the end behavior. We could also write the end behavior as a limit, but we're not going to. Any intercepts? So we do have an x-intercept at 0. So if I plug in 0, the answer is 0. That means it's also a y-intercept. And then we're going to graph it. So when I graph this, 1 and 1/2 is a whole. X equals -1 is a vertical asymptote. Y equals 1 is a horizontal asymptote. And now I just got to curve and understand the behavior. So 0, 0 is an intercept. So this is going to curve up to the right and follow the end behavior. It's going to curve down because it only has a choice of going to -infinity or positive. So the curve is following. It's decreasing here. What type of asymptote is it? So if I look at the denominator, the exponent you didn't see is +1. That means it's an odd exponent, which means on the other side it's going to +infinity, and again it's going to curve and the end behavior. That's just a sketch of the graph. Done. 56. Can you do the limit definition of a derivative to find that? So if I want to find the derivative for 56 using a limit definition, it's the limit as h approaches 0, and the function is 3x squared, so that's x plus h squared, and then x plus h for x. Subtract the function, use parentheses, and just plug in the function, which is 3x squared plus x, and that's all over h. So there's your setup. Now can you do the algebra involved here? So I need to expand. So we have a 3 in front, that's x squared plus 2xh plus h squared. That's plus x plus h. That is minus 3x squared minus x. So let's match up. 3x squared, subtract 3x squared. X, subtract x. So what does that leave me with? So the limit as h approaches 0, what I'm left with is 3 times 2, that's 6xh, 3 times h squared. And I have an h here, and that's all over h. I'm going to factor out an h, and then remove it. So factor an h out. Recognize from h squared, when you factor an h, you're still left with an h. Factor an h here, you're left with 1. Then notice the h's divide out. Plug in 0, and you're left with 6x plus 1. That is what the derivative equals. No shortcuts, the limit definition. And then if you do shortcuts, you can see, oh yeah, the answer was 6x plus 1. Use the alternate form for 57. So if you know the x coordinate, you can have a shorter form. So I want to find the derivative at 3. So the shorter form then is the limit as x approaches 3. So as it approaches that x coordinate, you take the function f at x, which is 3x cubed minus 2, subtract, plug in what the value is there. So if I plug in 3 to the 3, that's 27 times 3. Just going to stretch myself out here. 81. Take away 2. 79. And that's all over x subtract 3. This becomes 3x cubed subtract 81. Factor out of 3, and you have x cubed minus 27 over x minus 3. Now, if I plug 3 in, it's indeterminate. I can factor this. If you don't remember a difference of cubes, you can do this synthetically. So I'm going to do that on the side. I know positive 3 is a 0, so I'm going to divide it synthetically to do the factoring because I don't remember the formula. So we have 1x cubed, 0x squared, 0x, and negative 27. To divide synthetically, drop the 1 down, multiply, and then add, and then follow that pattern all the way across. Notice the remainder is 0. So we can now use that for the factor. So I know one factor here is x subtract 3. That's the 0 we divided with. And the quotient, what was left over, is 1x squared plus 3x plus 9. Now notice x subtract 3 divides out. Plug in 3 for your answer. That's 9 plus 9 plus 9. So the slope there, the answer is 27. Oh, do you know what I forgot? There's a 3 in front. So there's still a 3 that you multiply that time. So it's 3 times 27. So the answer is 81. 58. In 58, you have to find the A rock and the I rock. Here we go. So f at x equals 2x cubed minus 3x plus 2. So first you have to find the A rock. So if I want to find the average rate of change, it's slope. And we're finding the average rate of change between 0 and 3. So it's f at 3 subtract f at 0, and then x2 minus x1 does 3 take away 0. So if I plug in 3 to the top, 3 cubed times 2, negative 3 times 3, plus 2, and then simplify it. So plug in 3, and you get the answer. Figuring it out too. So if you plug in 3, I'll just write it out. 2 times 3 cubed minus 3 times 3 plus 2. Now, the good news is when you plug in 0, the answer is 2. And that's obviously 3. Notice 2 take away 2, so this is 27 times 2, 54, take away 9, 45. And then 45 divided by 3, the average rate of change is 15. So on average, it's increasing by 15. What's the IROC, the instantaneous rate of change? That's part B. So when I'm asked for the instantaneous rate of change, that's when you're asked for the derivative. And I'm asked for the derivative at an x value. So I'm looking for the derivative at 3. So I'm going to use shortcuts, and I can use limits. So the derivative, underneath I'll write down what the derivative is. The derivative of f of x would be 3 times 2, which is 6, subtract 1 to the exponent. The derivative of negative 3x is negative 3. And then the derivative of 2 is 0. So there's your derivative. Then plug 3 in for x, and then solve it. So 6 times 9 is 54. Take away 3, that's 51. Done. 59. In 59, it says find an equation of a line tangent. So I'm given a function, f at x equals 6 times the cube root of x, and I want to do it at x equals 8. So how do I find the equation of a tangent line? So first of all, x equals 8. I need to know the y coordinate. So what is the cube root of 8 times 6? So the cube root of 8 is 2 times 6. And then I need to find the slope of that line. Well, that's the derivative. So to find the derivative, first of all, I'm going to write this as 1/3 instead of cube root. And then I'm going to do the power rule. So it's 1/3 times 6, that's 2. Subtract 1. Remember the quick shortcut to subtract 1. So 1/3 take away 1 is 1, take away 3, so it's negative 2/3. There's the derivative. So the slope, I'm going to plug that in, 8, negative 2/3. Now on the AP exam, you don't have to simplify it. I will for you, but you don't have to simplify it. You could just write that as the slope of your line. So if you did want to simplify it, you would understand this as the cube root of 8, which is 2, and then 2 squared is 4, but it's going to be the reciprocal of 4, which is a quarter. So the negative exponent means reciprocal. Then when you multiply this through, you get 1/2. So there's the slope of 1/2. Now put it all together. So then you have y equals, the slope is 1/2. The x coordinate is 8, so it's x subtract 8, and then the y coordinate is plus 12. Done. There is the equation of the tangent line. All right, we're going to stop there. I'm going to pick up at number 60 for the last part of this assignment.